Imagine a computer so powerful it could solve problems in minutes that would take today's fastest supercomputers thousands of years. Welcome to the world of quantum computing, a technology that promises to revolutionize everything from medicine to cybersecurity. In this video, we'll break down what quantum computing is, how it works, and why it's so exciting. Get ready for a journey into the future of technology, explained in a way anyone can understand. Quantum computing is a new kind of computing that uses the principles of quantum physics to process information. Unlike classical computers, which use bits to represent either a 0 or a 1, quantum computers use qubits, which can represent both 0 and 1 at the same time. This allows quantum computers to perform complex calculations much faster than traditional computers. But what does that really mean for us? Let's dive deeper. Classical computers process information using bits, which are like tiny switches that can be either on or off, 0 or 1. Quantum computers, on the other hand, use qubits. Qubits can be both on and off at the same time, thanks to quantum mechanics. This difference means quantum computers can handle much more complex tasks, opening up possibilities that were previously unimaginable. Let's break it down further. A bit is the basic unit of information in classical computing. It can be either a 0 or a 1. A qubit, the basic unit in quantum computing, can be a 0, a 1, or both at the same time. This is called superposition. Because qubits can exist in multiple states, quantum computers can process huge amounts of information simultaneously. Superposition is a fundamental concept in quantum computing. Imagine flipping a coin. In classical computing, the coin is either heads or tails. In quantum computing, it's as if the coin is spinning in the air, being both heads and tails at the same time. This ability to be in multiple states allows quantum computers to explore many solutions at once, making them incredibly powerful. Another key concept is quantum entanglement. When two qubits become entangled, their states are linked, even if they're far apart. Changing one qubit instantly affects the other. This strange phenomenon is unique to quantum physics and is one reason quantum computers can process information so efficiently. Entanglement enables faster communication and computation. Quantum computers can solve certain problems much faster than classical computers. Because qubits can be in multiple states and entangled, quantum computers can process many possibilities at once. This makes them ideal for tasks like searching huge databases, simulating molecules, and optimizing complex systems. Their power comes from the unique properties of quantum mechanics. Quantum computing could transform medicine. By simulating molecules and proteins, quantum computers can help researchers discover new drugs faster and more efficiently. They can model complex biological systems that classical computers struggle with, potentially leading to breakthroughs in treatments for diseases like cancer and Alzheimer's. Quantum computers could change cybersecurity forever. They might be able to crack codes that are impossible for classical computers, making current encryption methods obsolete. At the same time, quantum encryption could create unbreakable codes, keeping data safe from hackers. The future of cybersecurity will be shaped by quantum technology. In finance, quantum computers could optimize portfolios, predict market trends, and manage risk more effectively. By processing vast amounts of data and running complex simulations, they could help banks and investors make smarter decisions. Quantum computing could lead to faster transactions and more secure financial systems. Quantum computing will accelerate scientific research. Scientists can use quantum computers to simulate complex physical systems, solve equations, and analyze massive datasets. This could lead to new discoveries in physics, chemistry, and materials science, pushing the boundaries of what's possible. Despite its promise, quantum computing faces major challenges. Qubits are fragile and can lose their quantum state easily, a problem known as decoherence. Building stable quantum computers requires advanced technology and careful engineering. Right now, quantum computers are mostly experimental, and their practical use is limited. Quantum computers need to operate at extremely low temperatures and require precise control. Errors can easily creep in, and scaling up the number of qubits is difficult. Researchers are working hard to solve these problems, but it will take time before quantum computers become widely available. Google is one of the leaders in quantum computing. In 2019, they announced quantum supremacy. Their quantum computer solved a problem faster than any classical computer could. Google continues to invest in quantum research, aiming to build more powerful and reliable quantum machines. IBM has developed quantum computers that are accessible through the cloud. Researchers and students can experiment with quantum algorithms using IBM's online platform. IBM is working to make quantum computing more practical and available to everyone, pushing the technology forward. Microsoft is taking a unique approach to quantum computing, focusing on developing stable qubits and scalable systems. Their Azure quantum platform lets users run quantum experiments and simulations. Microsoft's goal is to make quantum computing a practical tool for businesses and researchers. Quantum computing is often visualized with glowing qubits, digital worlds, and swirling quantum particles. These futuristic animations help us imagine the incredible power and complexity of quantum machines. Data visualizations and easy-to-understand graphics make quantum concepts accessible to everyone. Quantum computing can seem intimidating, but it's important to remember that you don't need a physics degree to understand the basics. With simple explanations and clear visuals, anyone can grasp the key ideas. Our goal is to make quantum computing exciting and approachable for all viewers. The future of quantum computing is bright. As researchers solve technical challenges, quantum computers will become more powerful and accessible. We may see breakthroughs in medicine, security, finance, and science. Quantum computing could change the way we live, work, and solve problems. Quantum computing may become one of the most important technologies of the 21st century. Its potential to solve complex problems, accelerate research, and transform industries is unmatched. As quantum computers evolve, they will shape the future in ways we can only begin to imagine. If you're fascinated by quantum computing and want to learn more about AI, technology, and the future, subscribe to RawTech Explained. We bring you easy-to-understand explanations and exciting insights into the world of cutting-edge tech. Stay tuned for more videos that make complex ideas simple and fun.